Good morning, everyone. My name's Andrew Tipping. I'm the commercialization manager at Catapult. One of my roles in Catapult is to work with companies trying to help them bring new technologies into the offshore wind sector. And in my experience, we've been, finding companies solving industry challenges and then looking for potential grant fundings to help commercialize them and putting in grant applications, going through that rigorous process and getting some successes. And then occasionally, you'd get one through, you'd get £1.5 million project funded. And then the project would fall flat because they couldn't get the match funding to support the project. And I thought there's something missing here and we need to engage more with private investment communities. So that was the aim of this program fundamentally, was to try and get more involvement from private investors into offshore wind innovation, so that we wouldn't have these great innovative projects that had all the right ingredients falling flat because they hadn't managed to line up the private finance. So that's why we're here today. I'm just going to give you a little rundown of how this competition is going to work. So hopefully you're aware, but the competition is live. That opened on the 26th of April this year. We're actually at the launch event, which you can see along the timeline, 14th of May. And then there's several weeks now until the competition closes on the 21st of June, 2018. So I hope that's enough time for you to put something together. So it's eight weeks in total. And then there'll be a couple of weeks where we'll sit down with ScottishPower Renewables and we'll be assessing your applications. And we hope to come back to you before the 5th of July this year. And beyond that, there'll be a handful selected from that group of winners who will then be invited to pitch to ScottishPower Renewables. And if they require investment, they will also have the opportunity to pitch for investment as well. So I understand some people won't need it, but we hope that by bringing the investors in, there's the opportunity at least to have that joined up. And from their perspective, the whole process is being de-risked because you've got an end user involved who's telling people what they want, and the innovators are coming through a structured program. So hopefully that should make it very attractive for the investors at the end. And so we imagine that pitch event will take place in July this year, or maybe early August, just depending on when we can get the right people around the table and summer holidays and the rest of it. So you're probably wondering, what is the prize? What happens? Because no one's really talked about money yet. So there isn't a specific financial pot for this, but the opportunity is to pitch your innovation to ScottishPower and also to pitch for private investment. And so the idea is that you could secure investment for further R&D. You could also set up a demonstration project, either with ourselves or by having ScottishPower involved in the program. If they see an innovation they really like and it gets to the right TRL level, there may well be opportunities to demonstrate that technology on the East Anglia 1 project, where they have 5 turbines allocated for test and demonstration of new and novel technologies. So whilst we don't have money in the pot specifically, we do have private investors ready to invest should they see the right innovation come along. And then we also have a route to market with both ourselves and ScottishPower. So to support that, we can also look at potential grant funding opportunities, because I think we could put together a pretty good project consortium if you've got an end user, Catapult, and an innovator going in responding to an innovation challenge. So those are the outcomes that we're looking for from this project. So I hope that's a bit clearer for you now. So we've got 4 challenges. Subsea cable fault detection, subsea survey of cables, jacket foundation to pin pile connection, and wind measurement on individual turbines. So these 4 challenges will be, you'll have seen them in the event brief, but we've got 4 presenters, 3 from ScottishPower engineering team, who are very lucky to have come along today to do the Q&A, because I think that's where the real value for you guys will be, is the opportunity to ask questions directly of the people who are facing these issues, these problems, or have a desire to see smoother operation, cheaper running costs for their offshore wind farms. So, that's the whole idea behind today's today's event is for you to have the opportunity to speak directly with them to help shape your ideas and shape your innovations. So the competition's online. We have set up a portal on the Catapult website. The link's on there. We'll share these slides at the end so you don't have to write what is quite a long URL. So you can go through the Innovation Challenges portal and then go onto the Offshore Wind Innovation Competition. You'll see there it's co-branded with ScottishPower and Green Angel. And then the 4 challenges are listed there, and you click through and there's quite a lot of background detail on the challenges. So if you don't, pick everything up in the presentations today, you can have a look through the website. And then beyond that, you can click apply now, and that will take you through a series of questions. So just going to talk briefly about the application itself. So there'll be a couple of questions, just basic stuff on company information, but yeah, in section 3, we'll be asking what is it, what are the key benefits, how does a short summary basically of your proposed solution. The next question will be on TRL. So we're looking at things, well, technology concepts between TRL 3 and TRL 9. Obviously, the sweet spot is slightly higher for ScottishPower, but perhaps five and above really. But if we do see something in the earlier TRL that's really interesting, that's not going to stop us from looking at it further. So whilst we have an ideal kind of bandwidth, that doesn't say that others will be excluded. So the other question will be on IP. Have you got patents in place? Are you in the process of applying for patents? And this is possibly the most crucial question, which is how are you addressing the challenge? So how is your technology meeting the needs and requirements of the challenge? And you can draw upon how it's perhaps been utilized in other industries. And we'd also like you to think about the potential cost impact and the efficiencies that you could produce through introducing this new methodology or new technology, and also the wider benefits like impact on health and safety as well. So yeah, just think about how it addresses the challenges and the wider benefits in that question. Another crucial one is the additional development required. So how is this going to take, well, what additional development do you require to take you up the TRL and then into the commercial readiness index? So taking it from a hypothetical commercial proposition up through to commercial scale up. So do you need a full scale test and demonstration? How much money do you need to do that? So I want you to think about each of the steps that you're going through, your sort of technology development pathway and the costs involved in that. And have you got partners on board to execute that project? Also want you to think about the risks, both the technical and the commercial risks in bringing that technology through, and also how you plan to mitigate them. That's the key. And then finally, a question on the company. So what is the team? Because we're going to be thinking, do these people have the ability to execute this project? What is their experience? If there are weaknesses or areas where they don't have the expertise, do they have sufficient relationships with partners to make that a reality and to bring that technology through? So the selection process, so we're hoping plenty of innovations will be coming through to this consortium. We'll be sitting down with ScottishPower to review your applications, and we expect to take 2 concepts per challenge forward. Now, that's not to say, if we get 3 or 4 absolutely, stonewall brilliant concepts for one particular challenge, we may take on more. We're not saying 2 is the absolute limit, but that's kind of what we're aiming for. We're not going to be too strict on that. So just to give you a quick example of where we have worked with an SME coming through this type of process before, and what was really the start of coming up with this investment innovation challenge type concept, which we were working with a company called Rovco, who a Bristol-based subsea services company, and we helped them to secure an Innovate UK grant. It was 200K to test and demonstrate a novel 3D visualization technology for subsea survey. they needed to find match funding to support the grant. So we introduced them to Sustainable Ventures, who put in 150K investment as an initial seed fund. And then they went on to secure a second round of funding, which was included a consortium of investors, including Green Angel Syndicate, who put in 160,000. And then there was a total of 1.3 million invested in total. And that obviously is supporting the commercialization of their 3D subsea survey technology. So this is the type of example we want to see coming out of this program. And yeah, we hope that was the whole reason for setting this up, is to make these types of projects happen. So yeah, all I can say now is good luck with your applications. I hope to see some interesting innovations coming across my desk over the next few weeks. And yeah, look forward to seeing what comes out of this. Thank you.
Thank you, Andy. We're doing okay for time, actually. So I wonder, before we invite ScottishPower and Green Angel Syndicate to talk to us, perhaps we just pause there. There's been a lot of broadcasts to you guys from the Catapult. Does anyone have any questions they'd like to direct at me, Andy, or Andy around what you've heard so far? Yeah, hi.
Are you open?
Oh, sorry, yeah, for our friends online, they won't be able to hear otherwise.
Are you open to innovations from consortia?
Yes. Yes, we are.
That's a yes.
What are the criteria for being accepted in the test site?
So we've got ScottishPower talking shortly, and they'll be talking about the demonstration site that they've got allocated at East Anglia 1. But I imagine that one of the criteria will be that you are to a certain TRL level, so you've proven in a lab and you're ready to go out into an operational environment. We can certainly do some of the testing in Catapult to get you to the level where you can then go offshore. But yeah, so I imagine, well, I'm sure ScottishPower will shed more light on that in their presentation, but it's going to be high TRL. But there are test facilities in Blyth that can get you up to a point where you will be able to go out offshore and prove it on, because it may be a case that somebody's taking a technology that's already proven in another industry and bringing it across. So it might be quite high anyway, and I can imagine that not being too much of an issue. But yeah, we'll hear more from ScottishPower shortly.
Hi, what are the sort of values of the projects that you think will be coming through, that's likely to be funded? 50K, 100K?
So I guess what we're seeing is it could be regarding like VCs and angel syndicates. They can look at stuff between 100K into the millions, but we're anticipating similar to the sort of Innovate UK size projects. If it's relatively early stage, then I think there needs to be an initial feasibility. So sort of up to 150 type K, and then but if it's full on test and demonstration of quite a large scale type technology, say perhaps for the jacket pin pile demonstration, then I think we could see projects into the millions. So I wouldn't like to put a cap on it because we're not constrained by public funding here. This is more, what would private investors be interested in, and they can go up further than say the Innovate UK funds could. So yeah, I think it's yeah, I wouldn't like to put a limit on it, but I wouldn't imagine we'd be seeing projects larger than sort of 3 million really. But yeah.
I was wondering what stage Roveco are away from getting a finished product.
They're currently doing demonstrations in they're doing wet tests. I know they have a similar technology that they're already deploying on wind farms, but there's advances in the autonomy. The 3D visualization technology is developed. They're now doing advances in making it into a fully autonomous service. So they're already deploying that technology on offshore wind farms now, but there's some further development that they're going through. And I believe Brian Allen is actually hightailing it across from Bristol, but apparently trains were pretty bad this morning. But he'll be around this afternoon, so you can have a chat with him.
Excellent. Okay, thanks for that. And actually, just in terms of, just so everyone in the room knows who they're with, maybe it might be helpful actually just to have a bit of a show of hands in terms of, who's here in terms of people who would consider themselves to be an innovator or a solution provider. Could you sort of put your hands up if you're sort of here because you think you've got a solution to these challenges? Yeah, right, great. And so the rest of you would you consider yourselves to be sort of investors or stakeholders interested in seeing a solution or an outcome? Who are the investors? Yeah, great. Some public sector money there as well. Excellent. So the rest of you, where are you from? Just interested stakeholders? Yep. Okay, great. Well, welcome. That's good to know. Thank you. Okay, well, I think we'll capitalise on the 10 minutes or so we've made up in time. And I'd like to invite our next speaker, who is Taylor McKenzie from ScottishPower Renewables, to come and talk to us, I think more generally around what ScottishPower Renewables plans are in the offshore renewable space.
Fantastic. Not my contact details, but there you are. I'll do the plug for the Catapult. Great. So yeah, good morning. My name's Taylor McKenzie, Innovation Analyst at ScottishPower Renewables. First of all, just thanks very much for having us along. Thank you to the Catapult for inviting us to be involved in this programme. Thank you for setting up the venue today and for all the logistics. Thank you to my team who have come along and supported the SPR on this programme. And lastly, thank you to everyone else who's made the journey. I think Madrid's as far as I've heard someone travelled, but it's good to just have people showing an interest in a programme which, as far as that, or is something I keep saying on paper, it sounds fantastic, and I don't know why it's not happened sooner. So yeah, just a thank you from me. I'll be giving a fairly sort of broad overview of who we are, SPR, part of the Iberdrola group, a little bit about the innovation team, what our priorities are, and just a little bit more trying to focus where we fit in and what we really see the value coming out of this programme and what we kind of see ourselves offering as well. So as I said, SPR, part of Iberdrola. Please forgive the mandatory who we are slide, talking about big capacity, installed capacities, and well, who doesn't love a league table now and again? But yeah, Iberdrola, global utility company. In terms of the renewable capacity, we have just over about 29 gigawatts installed capacity. And that's majority made up of onshore wind, some solar creeping in there, some hydro assets, and also, as we'll kind of explore, offshore wind making its way into that portfolio as well. Andrew, I think, already mentioned, or perhaps Stephen already mentioned our portfolio in the UK. So West of Duddon Sands, our operational wind farm, a joint venture with then Dong, now Ørsted. Also, we've got our sites in Germany in the Baltic Sea, Wikinger, another operational site. But the one that I kind of want to focus on is what we've got in the UK, EA1, and the test site there has already been referenced to. There's certainly an appetite for us to look at installing, we are an end user. That's a position, a role that we're playing in this programme. So the opportunity to capitalise on that and install these solutions, these innovations on some of our sites, hopefully that gives you a picture of what's there, of the potential end uses. And it's global as well. So this pipeline stretches out for at least 10, 12 years. So yes, if the timing's right, EA1's an option, but what I'm trying to say is it's not just that, and there's plenty up there. So as I said, I'm part of the innovation team. We're, until very recently, a very large team of two, myself and my manager, who's up in Glasgow. But we've now got two dedicated offshore innovation experts who are within the engineering team in SPR, and that's kind of a really, I think, significant and shows how much our interest is innovation. A very competitive environment. We're seeing how important cost reduction is, And as this industry begins to mature and we see aging assets out in the water, how much, yes, cost reduction, but also optimization of those existing assets is going to be. This just kind of gives you an overview of the kind of 4 avenues we use to explore innovation. So starting up top, industry, having a look at some of the attendees on the list today. We collaborate with our industry peers, share data, share ideas, share the headaches, and we get more value out of that when we explore innovation as a collaborative team, as a consortia. The one point I really want to bring up on this slide is really the supply chain. I think that's most relevant today, and it's a point I kind of want to labour. The ORE Catapult, I think Stephen said 4.5 years now, they've really cemented their role in the industry as being a voice that represents both sides of the table, the supply chain, the end users, the developers, and that's a really kind of great avenue that we look to continue to explore. You know, it's one voice, but one voice of many, rather than us ourselves doing it directly, and that's a really valuable route for us to engage with the supply chain. I've got up there academia as well, so that's the kind of 5 agreements we have globally with a lot of educational institutions, MIT over in the US, for example, Strathclyde Uni up in Glasgow. And I think one of the real benefits out of that is we've brought together academia and industry. So with Strathclyde Uni, we have an agreement with well, ourselves, SSE, Wood Group and the university to really kind of push forward R&D and innovation projects, and that's been a massive help to the business, and something we're really quite proud of, and it has existed for about 5 years, and we're now looking to extend that further. Lastly, what I've got there is SPR Futures. So this is a kind of example of our open innovation approach. Again, today, trying to enhance that open innovation, looking to the supply chain to collaborate for innovation. But SPR Futures is something we run internally. And it, as I say, a large team of 2 until recently. I'm no expert in every single bit of the field. So what it's really doing is calling upon the experts within our organization to think differently, think about the improvements we can do. Innovation analyst, but by no means the ideas person, a facilitator, a coordinator, and it's just about harnessing the ideas that we have internally, and that's how we kind of explore that. So that's kind of how we operate. What do we want to do? What do we want to achieve? Forgive this very high level slide, which just talks about reducing losses and increasing output. I know it's not quite as simple as that, and I wouldn't dare try and simplify it too much. But what do we want to do? Well, Iberdrola, large installed capacity, one of the oldest portfolios in Europe, I believe. We want, with all that stuff that's in the ground, we want to basically get as much out of it as we can. We think it's really important, and one of the kind of big priorities for us right now is making sure that renewables are a benefit and not a hindrance to the electricity network. You know, wind energy, with wind energy, more wind energy coming on and less conventional coming off, we're hearing a lot of headaches from network operators, but we want to flip that around and say, actually, this is an opportunity for renewables to support the grid. And that should really help us in our transition to a more renewable integrated energy mix. Another kind of achievement we want to do, and again, very broad, digitalization. This is something that's a massive priority for the innovation team, and it seems to be very much the way that the world's moving. But what does that really mean to SPR? Well, forgive my very simplistic view of it, but here's our digitalization dartboard, for want of a better term. And out on the outskirts there, we've got big data. Now, 29 gigawatts of installed capacity, high frequency data coming in, telling us what's happening on the wind farms. We're at the big data bit, but now we need to get to the inner, move one circle into the smart bit. We need to be making informed decisions about what we're doing with our assets based on the information that we have at our disposal. And then as we move even closer in, how can we get to connected systems? So the European projects that Iberdrola is working on, SPR supporting with the resource, Romeo. And this is really looking at how we have got all these systems in place. We're starting to make more informed decisions, but how can we get these systems talking to one another? It's all good having the best tech on the turbine, but if we're not accessing that information and understanding how our assets are operating, then what real use is it to us? And there we are, you know, I've got combining technology suppliers with service providers. Well, today is about getting the supply chain and the innovators in, and hopefully we can answer some questions. I think the real value today is the Q&A session, and you can we can flesh out what those problems are and how best to address them. just a kind of last point for me. So collaboration is a key point of the innovation that SPR does. And we've spoken a lot about EA1. Well, we're a big company with the resource to manage several contracts. So in terms of our UK content, but also what these projects offer in terms of opportunities for innovators, SMEs, we're very much aligned with, I think, ORE Catapult's appetite to get the SMEs and the innovators involved in our projects. And just a bit of plugging as well, this is some of the content that we've seen from our work in the UK and the economic impact of these projects, and we're looking to replicate that with the work that we'll be doing in the offshore wind industry in the UK. Just some last bits from me, my contact details, and if anyone's tweeting or LinkedIning, then please give us a drop us a message and at us in. That's very much everything for me, very high level, but I'm around for the day, so please just ask me a question or get in touch.
So do you want to take a few questions?
Absolutely, yeah, more than happy to. I think we should maybe just address George's question from earlier about the criteria for the test site. I wish there was a straightforward process and criteria that we had, which was just a box ticking one. Fundamentally, if it gets the thumbs up from the team that are involved now, we have the facility, we have the connections internally to take that up to where the decision will ultimately be made. We're doing quite a lot of work to make as many people within the business with that kind of decision-making power aware of this program, and fundamentally, there's a lot of talk about what the TRLs are. Obviously, if the timing's right and it works, then it'd be great to implement things straight away. But also, I think it's just quite important that we look at, as I said, the pipeline there. This has the investment, the end users ourselves, but we've tried to do something that's representative of industry. So there'll be opportunity within our pipeline, but hopefully a wider pipeline pending the outcomes and development we see following on from this program. So perhaps not the specific answer that I can give you, but we're working on that to make sure there's maybe a clearer pathway for that.
Has anyone got anything else they wanted to ask Taylor at this stage?
What's the timescale on the demonstrators for East Anglia 1?
So East Anglia 1, I mean, we're beginning offshore construction at the moment. I think some of the challenges we've looked at, and there's definitely scope for a retrofit, so the timing's not so much of a worry in my opinion, and I've confirmed that with some of the guys here today. Without completely bouncing the question, I would like to stress that it's not just East Anglia. Let's not just think about East Anglia 1. The challenges we put forward from an investment point of view, we wanted to make sure there's a wider market for it. If we just came and said this is SPR and we'll do all this and don't worry about our competitors, that wasn't our thoughts here. Our thoughts were very much what's the wider market for this, what makes a good investment. We're not investors, but we tried to get the investment hat on a little bit. And as I said, there's a global pipeline there, and that's inspired some of the challenges that we've put forward. So yes, as I say, without bouncing the question, hopefully we don't focus too much on the timescales and more on the solutions and the technology, and those things will follow.
Yeah, just looking through the briefs and that type of thing. Have you got any more detailed performance criteria or prioritisation that you'd like to look for? So, for example, you're looking to reduce costs. Is a priority CapEx or OpEx? Are you looking for a term of performance? Are you looking 8 years, for 20 years? Are you looking at particular types of turbines? Is there anything else that you kind of can give us in the briefs, or is it just open criteria?
In terms of the kind of technical requirements, we've got a team of guys along today that can hopefully pick up a wee bit more on that. Yeah, unfortunately, I wouldn't be able to really kind of shed too much light on that. But I'll give you my contact details and we can pick that up with you separately if need be.
That might be a question we can pick up in this afternoon's session, where we'll have our panel of technical experts up here as well.
Just one question over here. I probably don't need a mic. How broad is your remit?
Sorry, for the video.
Oh, sorry.
Yeah.
Fair enough.
I'll start again. How broad is your remit with regard to sort of identifying new solutions? Are you also looking in the storage space, distribution space?
So my role specifically is SPR UK Innovation. So I work geographically in the UK, but across all technologies. Storage is a great topic, very much on our plate at the minute, among many other things. So let's pick up on that and discuss further.
Let's not hijack this meeting for that. All right, thank you.
Sure, cheers.
Excellent. Okay. Well, is this working at all? Yeah. Oh, it is. Okay, great. So let's pause there for now. Taylor, thank you so much for that.
Thank you.
Are we going to be seeing you a bit later on this afternoon as well?
Yes, I'll be around today.
Excellent. Okay. Thank you very much indeed.
Cheers.
Okay. So our final speaker before we break for lunch is Nick Lyth, who is a sorry, did I get that wrong, Andy? No. Nice. Apologies. Nick Lyth, who is one of the founding partners at Green Angel Syndicate. So welcome to the stage.
And I need to speak through this for reasons that is this a webinar? And is that on?
Yeah.
Could we have the lights turned on, please? We'll turn this off. Thank you. Yes, thank you very much, Andrew, and thank you very much, OREC, for including us in this competition. It's a real pleasure to be part of it, and it's very exciting for us for reasons that I'll explain. But before I do that, I'd like to just check one other thing about the attendance in the room. Of the people in the room, how many of you would describe yourselves as entrepreneurs? Are all the people who are holding their hands up the people who held their hands up when they were asked whether they were innovators or inventors? There's nobody missing from that list. Good. What I'm going to talk about is really addressed to you more than anybody else. And I'm going to explain what Green Angel Syndicate does and how we do it and why. But I'll do that comparatively quickly. What I'm really going to use the talk that I've got now for is to explain to you how you can do something to help yourselves engage with people like us and give yourselves a better chance of getting investment. So really, I apologize to everybody else in the room. I hope you'll be interested by what I say, but it's not particularly addressed to you. It does relate to what OREC and ScottishPower Renewables are doing, and again, in ways I'll explain. Green Angel Syndicate is a conventional angel investment syndicate. In other words, it's a group of members who invest in startup or early stage companies with a view to achieving an exit at a multiple some years later. They know that it's very, very high risk, and they may lose all the money that they put in. But equally, they know that there's an asymmetric upside. In other words, it's the most attractive investment there is, because you know precisely what you can lose, and it's limited. You also know that what you can get is almost unlimited, and it's much, much more than double, treble, quadruple, which in themselves are very attractive returns. So we are a conventional angel syndicate, but for one thing, we're the only angel investment syndicate in the United Kingdom that specializes in making investments that are of benefit to the green economy. We're one of the only angel syndicates in the UK that specializes at all. And that's quite an important point. Angel syndicate investment is such a shallow growth level that there are so few of us that most syndicates really do everything. The benefit of specializing is that we attract a lot of people who know a lot about the areas that we invest in, and that means that we can de-risk more effectively the investments that we make because we know more about the sectors that we're investing in. The cruel truth is at the end of the day, they are still enormously high risk, and it doesn't matter how much you know about a market sector or about a technology. If you're investing in a company that is a startup or early stage, the risks are enormously high, and there's no way that we can remove those. So our presence here is really driven by the appeal for us of being able to connect up with the industry sector that we're investing in, personified by ScottishPower Renewables and by OREC. We can connect up with the industry one of the industries that we're really interested in, and ask the industry what interests it, so that when we invest, we can invest in companies which have a channel through to what we would hope will be sales. And the beauty of the competitive structure that OREC has set up is that, of course, that then provides a hierarchy that is judged by ScottishPower Renewables as being most suitable for its needs. And that therefore becomes, in terms of de-risking any investments that we might make, it adds an enormous layer of due diligence to the kind of work that we do to understand where the risks really lie. And so this, it's in many ways a visionary thing that OREC's done, which is completing the circle in setting up the panel that considers the entries to the competition that it's established, so that there is a circular process through technology, judgment, investment, and ultimate customer. Which then brings me to what I really want to talk to you about. I want to talk to you about the things that make us interested and make us convinced to invest in the companies that we invest in. And it boils, the message I'm delivering today boils down to one very simple thing. If you can't sell it, you can't succeed. Now, that's a very, very difficult and harsh thing to say to a room full of inventors and innovators, but it's not a harsh thing to say to a room full of entrepreneurs. And that's why I asked the question that I asked at the beginning. I'm going to say something else that may be enormously unwelcome in the context of this competition. Technology doesn't matter. Good ideas are to a penny. What's difficult is selling them at a price that allows you to make a profit so your company can succeed, and continuing to sell them in such a way that you maintain that company for years. That's difficult. The invention that this competition is all about, and that's why it's such an unwelcome thing. I can only apologize, Andrew, but nevertheless, I'm going to say it. The invention is the easy bit. The challenge is selling it. If you can't sell it, you can't succeed. Now, there's another corollary to that that applies to all of our environment, our economic environment. We live in a mature capitalist economy. The characteristic of a mature capitalist economy is competition. So let me rephrase what I've just said. Not just if you can't sell it, you can't succeed, but if you can't sell it better than the other people are selling it, you can't succeed. That means, and here's the real nub, if you can't sell it better than the people sitting next to you in this room, this is a competition. This is a competition between you and the other people who are going to be applying for the prizes in this competition. Now, you then might think of it in the context of investment, and that's another competition. That's not a competition to sell your technology the way this is. That's a competition to sell your equity. So when you come to us, you'll find yourselves competing against other companies that aren't run by the people in this room because they don't cover the technologies of the people in this room. Although we are specialists, we look at quite a lot of different sectors. Offshore renewable energy is one very narrow niche. It's a very interesting one and we like it a lot, and that's why we're here, but it is a very narrow niche. Even within renewable energy, it's a narrow niche. But then when you look at other aspects of energy, energy storage, and energy distribution, energy management, energy covers a large variety of different sectors. So even within energy itself, we could have you could be up against companies trying to get investment from us that are looking to us to judge them, who are selling equity in doing things that are completely different from what you're doing. That means that you have to understand how to sell what you're selling, when you're selling it, in the way that you're selling it effectively. And if you can't do that, as I said, you can't succeed. Now, let me help you with that. This isn't a mysterious skill born of curious personality traits that are developed over years that are only available to people who are as extroverted as me, for example. Far from it, it's the absolute opposite. In many ways, extroverts like me are the worst conceivable people to sell anything because we are so palpably insincere. The people that need to sell things are people that believe in what they're selling. That's the first and crucial message. If you believe in it, tell it the way it is, tell it with sincerity. And those are the most effective salesmen. But there's another aspect to doing this and how you do it, and the way in which you use a professional approach to a sales process. It's called the pipeline, the sales pipeline. When, for example, you set up your fundraising session, you create a sales pipeline of people who might buy your equity. When you're starting to sell your product, you set up a pipeline of people who might be your customers. In setting up that pipeline, what you do is create a phased process with the customer's name at the beginning, and at the end, the conversion into a transaction. That process is a timeline, and the timeline has certain milestones on it, and the milestones are events, which generally are meetings or presentations or maybe proposals, and you put them along that timeline. That is a sales pipeline. The reality of people's sales pipelines, and I have to stress, this is something that we will look at when we invest, and we will pull to pieces. The point being that an awful lot of people who don't really understand what a professional sales process is will put together a sales pipeline which is really a wish list. It's not real. We'll find that out because we'll phone them and we'll say, are you serious about considering buying this company's products? And they'll tell us. Why wouldn't they? The important thing in building up a pipeline is that it is a pipeline of real prospects, people you have met, people that you've spoken to, people that you've established a connection with, and they are interested and they are potential buyers of whatever it is you're selling. You then start to fill it in. And that, again, it's nothing to do with being a salesman. It's to do with being a professional at trying to develop the business of your company. That is one of those things that I find when I talk about this to people in the United Kingdom. It's one of those enormously uneasy things. We are all, as British people, incredibly loath to describe ourselves as salesmen or women. It's something that there's a stigma attached to it. If you go to America, absolutely the opposite applies. They are loath not to describe themselves as salespeople. And as a result, the culture there is commercially very different and much more exciting in many ways. The people who do what I do over there are linked to universities, linked to industry in a way that is far more active, whereas the angel syndicates here in the UK are like gentlemen's clubs, in fact. They're very, very sleepy. I realize that what I'm saying might be difficult, but nevertheless, it's what you've got to do. If you can't sell it, you can't succeed. How much longer have I got, Andrew?
So you can talk for another 5 minutes.
Another 5 minutes.
We'd still be
okay.
And if you have to take some questions after that as well.
Okay, 5 minutes and then questions?
That's okay.
All right, okay. So the next thing I want to talk to you about is how that then feeds into your business plan. And there's another very important point to make. So your business plan should really lead with what I've just described. How are you going to sell this? Obviously, you've got to describe what this is and who it's for, because that's who you're going to sell it to, and that's why you're going to sell it. And that then moves me into the second thing that I'd like to exposed to you as something that I hope might help when you start to approach people like me looking for investment funding. And that is marketing. What is marketing and why is it marketing? And there's another point that I'm going to make that's extremely unfashionable. Marketing is everything that happens to sell a product when the salesman isn't there. And that's all it is. There's a lot of nonsense talked about marketing, but that is the only thing that marketing is. Marketing was created when the Industrial Revolution made it very, very difficult for companies that were trying to sell their products to do so and be there. Before the Industrial Revolution, if you were a baker, you didn't have to, there was only so much you could make. You didn't have to go out and talk to the customers and sell it to them. They came to you. Much less did you have to go to the next town and try and sell it to them, which you didn't have time to do. Once industrial bakeries started, they could produce all of the bread and the cakes that their local town needed, that their county needed, that the entire region needed. And unfortunately, so could their competitors up the road. And that was the point when they started having to go out and get customers. There's a statistic that some who've heard me talk before might already know. David Duke in the United States bought the first cigarette machine in 1895. That cigarette machine could produce not only in a day everything that he sold in a year, but in a week it could produce the entire cigarette consumption at that time in the whole of the United States. David Duke, once he bought that machine, had a huge problem. What he in fact did was he bought every single other cigarette producer in the States and turned it into a monopoly, which the US Monopolies Commission had to dismantle in 1912, but that's another story altogether. So marketing is the process that we realized we needed to do when we understood that we couldn't ourselves personally talk to all the people that we wanted to sell the product to, which then allows me to, again, expose to you something that brings us full circle back to my first point. If you can't sell it, you can't succeed. Marketing is in many ways the process by which we work out the communication strategy. The communication strategy being, what are we going to say about this company's products that is going to be most effective in selling them to the people that we're trying to sell to in competition with the other people. And the concept of the USP, of course, is familiar to everyone and all that sort of thing. USP isn't magical. What's magical is finding the thing that is going to persuade them. Actually, what is it in that USP that is going to persuade them? And a lot of that is to do with how. How do you actually say it? What is the language that you use to persuade people? And of course, once again, it's competitive. You have to look at what is the language that others use. I mean, I grew up in London advertising in the last days of Purcell washes whiter. Who thought that Purcell washes whiter would be a line that convinced anyone at all? But in fact, it did. And the reason why it did was because it was wrapped up with a lot of imagery and a lot of quite clever television commercial work that in the late 1950s and early 1960s did persuade people to buy Purcell. But Purcell clearly didn't wash whiter. It was a lie. I mean, and I would not advise that you tell lies. I think perhaps that wasn't the best story to tell, was it, in the context of this conversation? So marketing. So that's the second part of my advice to you. Think about how you sell it. Start working on it now. Don't spend time. The more time you spend working out how you're going to sell it, the better. The more you concentrate on the technology development at the cost of working out how you're going to sell it, the worse. And so that brings us right back to the competition, because you're going to have to work out how to present it in these applications more effectively than everybody else in the room in order to win the competition in the first place. Thank you very much for listening to me.
Nick, thank you so much for that. That was fascinating. I'm sure many people in the audience now are thinking, well, I've got my idea, I've done the easy bit. What now? Would you be happy to take a few questions from the audience? I'm sure there are plenty. We'll just have to take a bit of time to run around with the mics. I want to try and capture this.
Yeah, just going back to your, if you can't sell it, you won't succeed. Green Angel Syndicate obviously focuses on the green, the renewable, the sustainable. In a lot of these cases, the technology is going to be multi-mixed use, so on and so forth. And following where the money or where the pipeline of funding and ultimate clients could come from, that might not be in the green energy sector. You know, you might be able to leverage capital from other sectors, which may well be outside of the green sector. What's Green Angels Syndicate's view on you know, those that you would follow through on, those that you would potentially not want to follow through on? Have you got any dynamics as far as that is concerned, or is it just wherever you can sell it?
Well, there's two aspects to that question. In terms of the companies that we invest in, we've got one or two red lines. If it is environmentally friendly, but actually what it's doing is something that is making the oil and gas sector more environmentally friendly, we won't invest. We won't look at anything that is promoting the continued use of the oil and gas sector. And there are one or two other red lines like that. If it's promoting something that is actually, maybe it's very green, but it's promoting increased consumerism, then we won't look at that either. In terms of following and who we invest with, we'll invest alongside any other investors. And as our portfolio companies get bigger and look for following rounds, we'll judge them in exactly the same way. So there are following rounds that we have not gone into because we haven't been pleased with the company. There are others that we have gone into because we have. We have never not gone into a following round because the company has started selling to something that we don't believe in. We've generally not gone into a following round because we thought it might be good money after bad, which is a different problem altogether.
Nick, I was wondering what got you into advertising in the first place?
I left university and I couldn't think of what else to do.
It's quite a unique field, like it's very, and the personal wash is whiter is like fantastic, like everyone's heard of that. I just wondered what, like.
Yeah, I loved advertising. I mean, I thought advertising was enormous fun, and I promoted all the things that I'm now trying to suppress. It's a very fast-moving industry. It suited me down to the ground. I was the salesman. I was what they call the account handler who went out and sold the ads to our clients, and indeed I took responsibility for going out and finding new clients for the agencies I worked in, and I liked it. There was a big buzz in the whole communications side for big mainstream consumer brands, and it was intensely shallow. You know, it was very showbiz related. It was very media related, but it was enormous fun, and I had possibly rather too much fun in the course of my 20s and early 30s before I married and started a family and realized I had to actually work for a living, which is when I started. I went and left advertising and went into marketing, in actual fact.
Nick, I was just wondering, in terms of your value proposition, in terms of selling yourself and Green Angel Syndicate, if I can turn it around that way. So obviously for companies coming to the funding, the investments, obviously the major part of it. Do you also take an interest in terms of mentoring, in terms of taking a role on the board? Do you have an active interest? Is there additional value that companies get from working with Angel?
Yeah, yes, very, very much so. It is generally true that when companies are looking for angel investment, they are wise to look for added value from the angels who they get to invest. They're always startup or early stage companies, and they can always benefit from the experience of the likely experience of the angel investors. With us, it's even more so. and in fact, the people who become members of Green Angel Syndicate tend to become members, both because they know the sectors that we invest in very well themselves, because they've worked in them, but also they want to get involved. And so it's one of our basic principles that we will put somebody on the board. But unlike most angel syndicates who put people on the board in order to monitor the investment and report back to the members, we put somebody on the board on the basis that they can actually help the company. And so yes, very much so. We want to do everything we can to help.
Perhaps I can ask you, in terms of, sort of the green space you've been operating in, to date, what have been the most fruitful areas that you've sort of found, and what are the sort of success stories that you can point to?
That's a sensitive question. It's an angel syndicate's measured by the success of its portfolio, and we are still slightly too young to have started to achieve the kind of exits that make members really, really happy. And indeed, in the short time we've been going, we've had one company in our portfolio go bust, which was not really what we wanted. That was a company in industrial wastewater treatment, and it was a wonderful company that we invested in the R&D stage. The TRL is, I was pleased you spent so much time on TRL, Andrew, because TRL is an incredibly sensitive point, particularly for investors, but for the life of your company, it's incredibly sensitive. We invested, it must have been TRL level 3. It was R&D, and when it scaled up, there was a molecular reactor. It was a photocatalyst, and when the catalyst was scaled up, there was a molecular reaction which blocked it, and it just didn't work. And so that was the end of that. We've had one exit which has been a little bit like that. It's some people have done well out of it, some people have done not so well. That one was in automotive energy efficiency. So that was heavy engineering. We've got another company in heavy engineering, but I would say the area where we are most active is in energy-related technologies, so energy storage, energy management, energy distribution. That's where we're doing our most. We, as Andrew explained, or was it Taylor, we are in Rovco. We've just invested in Rovco, which we like a lot. We really do. We've got high hopes for Rovco. But that was partly because it came out of OREG. So there's already kind of endorsement in there. I'm in a way, I'm prevaricating because there isn't a clear answer to your question. And it's work in progress because we want there to be. And in many ways, what we're doing with you here is a part of the process of finding out where the real fertile areas are by linking up with industry and understanding what it is they want.
Very good, thank you. And we might have questions online as well. I don't know, is anyone monitoring anything coming through? Do we have people online?
There are a couple.
Are they? Excellent. Okay, so we are almost at lunchtime. We've probably got time for a couple more questions. Is there anyone, would people like to extend any questions to anyone you've heard this morning? So I know it's been a fairly long morning, a lot to take in, but sort of you heard from the Catapult, how the challenges are running, ScottishPower Renewables portfolio, and Green Angel Syndicate. Has anyone got anything else they want to field? Is that enough for now? Okay, Andy.
Just a quick question. What's your typical deal size for your investment?
Yeah, at the moment, our typical deal size is between 150 and 200,000. We're trying to increase it. Our ambition is to get it up to 250 to 300,000. And we're doing that by increasing members and also by increasing the quality of our members. So we're looking for more. There's again, this is into the arcane world of angel investment. There is a category of person called a high net worth individual who is identified by, I'm not sure, probably by the FCA, a high net worth individual, and they're above a certain level of wealth. And they are the only people who are allowed to join angel syndicates. There is another category, which I think is informally recognized, which is ultra high net worth. And the ultra high net worths are the ones who are really very, 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 very rich indeed. We'd like one or two of those, Andrew. So if anyone in the room knows of anyone, if anyone in the room is one of them, please form an orderly queue later and I'll talk to you.
Thanks. Excellent. Wouldn't we all? Okay, so I think we'll probably draw a line under this morning's proceedings there. Lunch is, Andy, help me out here. Where will we find lunch? Okay, so, right. So back through where you came this morning, where coffee and croissants were served earlier. Perhaps I can just ask you to put your hands together, both for Nick and the other speakers that we've heard this morning. And we're going to aim to reconvene here for around 1:20 or so, 1:25. We'll call you to order, but in the meantime, enjoy your lunch and conversation over lunch. Thanks.
Afternoon, everyone. Settle down. So I hope you're all fed and watered for what should be the crux of the day, really, and the moment you've all been waiting for. So we have the 4 problem owners, or challenge owners, I should say, who will be presenting the specifics on each of the 4 challenges that have been put forward. And it's your opportunity, should you wish to take it, to ask them questions about the challenge and how your solution might fit their requirements. So the format will be, we'll run through the presentations one after the other, and then they'll all sit across the front, and there'll be a panel style Q&A session at the end. So without further ado, I'd like to invite up, the computer screen's closed down. What's your passwords? I think Ross is up next. Okay, so we got Ross Main from ScottishPower up first.
Okay, good afternoon everyone. Thank you very much for coming. My name is Ross Main. I am Senior Electrical Engineer for ScottishPower Renewables, and also doubling up as the Electrical Design Manager for the East Anglia 1 project, which is the latest project that we have, which is currently in manufacture/installation. Taylor's already covered the kind of background. I'll fly through this very quickly just to give you an idea of the project pipeline that we have. Obviously, we have several markets across the globe. We have a couple of operational wind farms west of Dutton Sands, and the Vikinger project, which has recently come online. And as I say, East Anglia 1 is currently under development, along with Saint-Brieuc in France. And we have a couple of interesting project opportunities in the US, off the coast of Carolina and Massachusetts. So just to give you an idea, today is not only about East Anglia 1, with the right innovations, the right ideas, we would also look at the other projects in our pipeline as well to see where it fits in best. As I say, key markets across the globe. SPR is a kind of recently acquired by the Iberdrola Group. So now we have main operations in the UK, Spain and Portugal, Brazil, Mexico and the US. Okay, the issue that I'm here to talk about today is the condition monitoring and fault detection in subsea cables. This relates to both array cables and the higher voltage export cables. As we know, subsea cables in the grand scheme of things only make up a very small fraction of the the capex cost of a wind farm. You know, you're talking very small percentages in terms of the purchase and installation of the cables when you consider the cost of the turbines, the cost of the foundations, the offshore substations, all the steel work and things that go into these. But around 80% of the claims to insurers from failures are related to subsea cable faults. These are quite delicate pieces of equipment, and it doesn't take much for a fault to occur. These can lead to, well, last year, the figures I have are claims of around 60 million euros. This only really relates to the assets themselves, the cost of replacing the cables, the work involved, the time itself. These don't actually cover the loss of generation, which could put that figure far, far higher, especially if you have a fault in the middle of February in the North Sea. It's not a quick or an easy task to resolve this. And that's where the majority of your generation losses can come from. As I say, subsea cables are expensive to repair, they're time consuming, they require spare parts, they require vessels, they require senior authorised people to be on site. All of these things, if you have a fault which occurs at random, you quite often don't have all these things on standby, and that's where you lose the time and hence the money. So the challenge is split into two sections, the first of which is the condition monitoring of the cable. Condition monitoring of cables is not a new thing. We already have things like DTS and DTSS measuring strain and temperature in cables. The challenge we are now looking at is how that we can advance these systems to provide more functionality, to reduce the number of systems that we currently have, to reduce the amount of equipment we have. We say continuous monitoring of cables. It may help to prevent or preempt failures and allow for better planning of spares. It's not practical to keep masses of cable joints on site. It's not practical to keep various pieces of equipment, terminations and the like. So by monitoring the cable and by predicting its performance, you can actually plan and act before a failure takes place, whether that be derating the cable, switching off a turbine, which is not really the optimal solution, but certainly derating the cable or taking kind of preemptive maintenance can help save money in the long run. The vast majority of subsea cables feature integral fibre optics. This is to provide things like protection, control, monitoring systems. And this is the avenue which certainly we in ScottishPower see as ideal to develop these new condition monitoring systems. The fibre optic is already there. Quite often there is a lot of spare in the fibre optic cores. And the cable itself is practically impervious to the effects of the power cores that it lies beside. So this makes it ideal in many respects. At the moment, as I say, we monitor parameters of cables such as strain and temperature by increasing the functionality to include things like insulation resistance, electrical loading, basically by measuring current and voltage. It would allow us to use systems such as we could potentially use dynamic cable rating, for example. We could also employ distance protection and other systems, basically removing all these other kind of systems and servers and pieces of equipment from the wind farm and replacing them with one simple system. Looking at the key parameters of any kind of innovation, obviously it's got to be low cost. There's no point developing something which costs 30, 40, 50 million pounds. It's got to be cost effective compared to what we already have. Providing real-time monitoring of the cables is also very useful. There's no point in amassing lots of data after the cable's failed and then you can go back and see why the cable's failed. We want to know in advance. Utilising the existing infrastructure. As we say, there's fibre optic cable there. This would seem like a key starting point, without dropping any major hints. Applicable across the lifespan of the cables. Typically, we would expect a wind farm to operate for a minimum of 25 years, ideally longer than that. So obviously the systems and supporting equipment has to mirror that, and low maintenance as well. Maintenance in terms of the operations side of the wind farm, the less work we can put in, the less money we can spend. Obviously, the greater the savings. One that I haven't actually put here that I should have put in is dual functionality. As I say, we have systems in place that can measure temperature, strain. What we need to do is try and advance those systems, develop those systems to provide additional functionality, whether it be for distant protection or dynamic cable rating. The second part of the challenge is the actual detection of the fault itself. Again, this is after the event. You know, if the worst happens and the cable fails, it's imperative that we identify accurately where the fault has occurred. At the moment, there are various methods of fault detection. We've got manual switching, which is a very basic system, whereby you have a fault on, for example, an array of a wind farm. One of the cables between two turbines fails. The main breaker will operate at the offshore substation, and then the process starts. We have an SAP who would go to turbine number 1. They would connect or close the disconnectors or breakers at that turbine, and then they would try to reclose the circuit breaker at the offshore substation. If the circuit breaker doesn't operate, you know that section of cable is good. You then move on to the next section and repeat until the main breaker trips again. And that gives you a very rough idea of where the fault is. You know the section of cable. It doesn't tell you exactly where, so then you have to either locate the fault or replace the section of cable. The other key, or the other main type of system is an active system, where you have voltage indicators, voltage detectors, fault indicators, and all the associated CTs and VTs which these systems use. Looking at the pros and cons, certainly this system tends to be faster than manual switching. You can send someone to the turbine, you'll get a nice green light on an indicator or a nice red light to tell you you have a fault in that particular section. It makes it more accurate, and it minimises any switching duty on particularly the circuit breaker or the offshore sub. Cons, again, this system requires a lot more equipment than your manual switching. So there are the pieces of kit that you have to purchase, you have to install them, you have to maintain them. Again, costs vary depending on the type of system, but we've valued it somewhere upwards of €1 million. But this could be anything to 3 million, depending on how far you want to take the system. So yeah, the levelized cost of energy can be reduced by minimizing these fault location times. Ideally, what we want is a system which can do both. We want to be able to monitor the cable in real time, so our guys back in our control room in Whiteley can dial into SCADA at any point and can look at the cable and say, well, at point X along the cable we have a temperature rise, and then we can either take action or we can monitor that section of cable. And if the worst happens, we want to be able to log into the system, press a few buttons, and we can see that section X of cable Y has failed, and we know exactly what parts we need. We can schedule the vessels, we can schedule the SAPs, and overall that will help us to reduce costs in the long run. So that's short and sweet from me. I don't know if we're going to do questions at the end. Thank you.
So thank you, Ross. Next up, we've got Andy Kay, who'll be speaking on Subsea Survey Chat.
Okay, afternoon everyone. My name is Andy Kay. I'm O&M Strategy Manager at the ORE Catapult. Clearly I don't work for ScottishPower. So I'm going to talk about the Subsea Survey Innovation Challenge on behalf of them. Hopefully I do it justice, and I have worked quite a lot in this area with some other operators and had discussions with ScottishPower about this. So hopefully I have a good enough background to introduce this challenge. Okay, so getting right into it. Subsea survey and inspection. So first of all, I'll give an introduction to this area if it's not, not aware of that, why it's done, and then we'll have a look at the current projects and some of the innovation requirements. So why do operators survey and inspect? So actually these activities are performed throughout the life cycle of a project, from cradle to grave. Really, there's a lot of opportunities here for a company developing a technology in this area. So first of all, survey will be done during the pre-installation phase. So this is while the project is getting designed. They're specifying the technology from the foundations to the cables, the substations, the turbines. All of this work will be informed by the site investigation, and this whole activity can take around 36 months. And that's not to say you're going to be doing 36 months of subsea survey and inspection. The market size is not that big, but the whole site investigation process usually takes around that time. So what's done? So this is really to inform the selection and design of the foundations and the cables, and also where they're going to be located. So you want to get enough information about the seabed so that you can effectively design the foundations, the cables, the substations, so that they can operate safely and effectively in that region. So types of survey that is carried out. First of all, it's a geotechnical survey, a geotech survey. So this is trying to understand information about the seabed properties and the morphology, which is really a fancy name for the mapping of the seabed. So something like this might give you some information on the sort of the hollows, any sand waves, sandbanks within the region of interest. And then you also want to know about the seabed properties, so the constituent materials that make up that seabed, because you're going to have to be burying foundations and cables within that region. Then you're going to want to do some kind of geophysical survey. So that's looking at the kind of dynamic behavior of the seabed. Is there any sediment transport, any seismic activity ongoing in that area that you should be aware about before developing any wind farm? And finally, a UXO survey, so an unexploded ordnance survey. So that's kind to locate and identify any UXOs that might be within the region. So obviously we want to avoid those. And then this all really, as I said, feeds into the design of the cables and the foundations, where they're placed and how the cables are going to be buried, because the cables for offshore wind farms tend to always be buried rather than some sort of cable protection, although that is an interesting area of development. So then once you've been through pre-installation and you've installed the wind farm, then you're going to do some installation phase survey. And this would be to verify that the installation has been done according to the plans. So this can usually take around 18 to 22 months. And there's really two types of survey that is done here. First one is an as-laid survey. So you're trying to verify that the position of the cables and the foundations, make sure they've been installed in the right locations, there's been no movement, and if there has been any, you can record them and account for that in your ongoing monitoring and maintenance planning. And then also an as-built survey will be conducted to make sure that the cables have been buried as specified during the design. And then post-installation, that's really where this is the most ongoing period of survey. This can go from commissioning, operations, right through to decommissioning. You're going to be doing some ongoing, and this can be very site-specific. So it can depend on the nature of the site, the types of survey that is done, an inspection, the frequency of the survey. It's going to be very operator and site-specific, depending on that operator's motivations and also the environmental conditions around the site. So one thing that most operators will be forced to do is surveys to adhere to their consent agreement. So a marine authority, depending on the region, will have said, look, you're going to have to prove to us that in the first 3 to 5 years of operation that your cables are remaining buried. This isn't a risk to the site. There's no major sediment transport around the site or global scour due to the general introduction of a wind farm within that region. So that's usually done, but then beyond that, it's really up to the operator's discretion. But they're going to be motivated to do some survey because they want to understand the cable condition. So maybe have some inspections there. The burial status, make sure that no cables are free spanning or exposed or moving, because that can create issues. And the foundation as well. So wanting to know information about the weld integrity of the foundations. So that's really the structural integrity, but then also scour around the base of the foundation. So what you can get is accelerated flow around the foundation base, and that can cause basically the seabed to erode, and that can then cause the turbine to potentially start moving or subside. And there's some evidence of that at Robin Rigg wind farm, competitors wind farm, should I say, where they had to have 2 wind turbines removed early on. I think it was about 6 years into operation due to significant scour around the seabed. So it can be a critical issue. And then, as I said, looking for general sediment movement, sediment levels. And actually, I am aware of quite a few sites that are having to do surveys because they are areas of archaeological interest as well. So who knew that? Okay, so the current approach and the limitations. So this is really what you're trying to overcome. So how it's done currently, well, there's 3 main techniques that are applied. The first one is really the main, and that is using vessel-mounted or towed sensors. So this image here, the first image at the top, actually represents this quite well. So this could be a vessel with some hull-mounted sensors, and that could be towing a buoy that would also have some sensors on it. And these tend to be acoustic inspection sensors. So the main types are side scan sonar. So that can be used for getting information about the properties of the seabed. Swath bathymetry, which is really looking at the seabed depth and for doing that seabed mapping. And sub-bottom profilers, which tend to give information about both properties and depth. But then once, and these are applied to do the general seabed survey. And what you'll find is an operator, when they're doing their seabed survey, will also select certain areas of the wind farm to do some direct inspections of some cables and foundations. It might be too expensive for every single survey to do a direct spot check of every single foundation and cable route. So what they might do is, on a rolling basis, every 6 months, segment off a section of the wind farm and do that section and that section and that section. So maybe every foundation and every cable route gets a direct inspection maybe once every 4 years. But if you could improve that frequency, the reason they do that is because it's expensive, but if you can increase that frequency, then you get more information about the asset. So when they're doing that direct spot check, they'll tend to use a remotely operated vehicle deployed from a vessel. So something like this could be deployed from the vessel. It might have sonars, magnometers, visual cameras on it. That can go down and do a spot check of a cable or a foundation. But it could also have NDT equipment, such as acoustic emissions equipment, so it can do a direct NDT inspection of a foundation weld integrity. And then finally, the last option that an operator will take is to send a dive team. But dive teams are used, and these will dive down, swim along a cable route, or do a spot check at a foundation, and they might have a probe for checking burial depth and burial condition, depth condition. And then also they'll be maybe doing some NDT checks of the foundation as well, which will require the diver to scrub away all the marine growth on the external surface of the foundation and then do direct acoustic emissions tests. So if you are going to get rid of the diver, you have to also consider that you're going to have to get rid of the marine growth as well before you do that, that inspection. Okay, so moving on to the limitations. So combining all these techniques together, really, the main limitation is these methods all require a very expensive vessel and personnel. So it's very labor intensive and vessel intensive. Now we have some figures, so approximately this can cost around £800,000 per year to conduct a survey using existing methods. Now those costs could go up or down depending on the weather. These techniques are all very weather dependent. So you can't deploy a vessel out there if the weather's extreme, so you might have standoff time with the vessel and the personnel. And then finally, they can be very high risk. You know, you're using divers, it's expensive, it's high risk. The industry just does not want to use divers. So that's the limitations. Okay, so what is the challenge? I've pretty much ripped this straight off the webpage because I don't want to invent what ScottishPower haven't said. So the main challenge is to provide a technology or some kind of approach that can provide a cost-effective subsea survey methodology for cables, substructures, and the surrounding seabed. So my kind of spin on that is that you want to develop a cost-effective technology that can, provide an improvement on the current approach, but also, gather equivalent data. So often people will focus on getting the cost out. We can do this much cheaper. But remember, you have to provide an inspection that gathers exactly the same quality of data, survey data, seabed data, asset data, or better than. I think the main improvement could be if you could increase the frequency of that data. If you can get some of the cost out, that might allow you to gather more data on the condition of both the substructures and the seabed. So, remember that it's not just about getting the cost out of the system, it's about making sure you can gather equivalent or improved data. And then the final one is really, I think, we don't want to narrow down the solutions too hard here, but the way you're going to get that cost out is to reduce the vessel requirements, the vessel and personnel requirements. We've honed in on here on autonomous technologies, so some way that you can go off and do all that survey inspection without using the vessel or the personnel. However, if there is some technology that can also minimize that vessel requirement, I'm sure ScottishPower would be interested to hear that. So on autonomous vehicles specifically, we're talking about underwater technologies that can reliably, so that's out there, gather data without breaking down and having to be maintained themselves, and safely navigate themselves around the wind farm. So you've got lots of seabed conditions, substructures you don't be battering into, so no risk to the asset, and gather that equivalent or improved data. Okay, so I think hopefully I've still got some time. So the test, so what might your technology be judged against? So these are some things to consider when specifying a technology. So some of the operating conditions that you're going to have to operate in are water depths up to 60 meters for fixed bottom offshore wind. So we're talking about monopiles that have been hammered into the seabed or jacket substructures. We're not talking about floating wind in this instance. And then up to, these wind farms can have cabling of up to 600 meters in length. So a fair bit of cabling you're going to have to track. And wind farms can be, up to 50 kilometers from shore and have areas of around 700 kilometers squared. So it's a very vast area that you need to cover with your technology that might inform some of the, the battery charging, the power requirements, the comms requirements for the technology. So on the data that you're going to have to capture, so things around the seabed morphology, slopes, hollows, sand waves, etc., and those properties. UXO, location and size, cable depth, burial and exposure, and stuff about the foundation. So scour, weld integrity, corrosion protection condition, that kind of stuff. If you can do all that in one go, great, but maybe try and split it into specific areas and nail those first before trying to capture all in one technology. And then a very important thing if you are going to be using autonomous vehicles is the comms and navigation. So you need to be able to locate these cable routes and track them. You need to be able to locate these foundations and inspect them and do all this without causing any damage to those assets. So, they're not going to be happy if you're colliding into those assets, causing damage, and also communicating. So as we said, it's a very large area. You've got to communicate data, receive commands, with very minimal vessel requirements if you're going to get that vessel cost out. And then charging as well. How do you charge that vehicle? If you still have to have a vessel to take the vehicle out there, deploy it, and bring it home again, it's not a huge cost saving. So if that vehicle could be permanently stationed offshore, how are you going to charge it? How are you going to communicate with it? How are you going to give it commands? So just to note, power and comms connections may be possible from the existing wind farm infrastructure. So something to consider there. Okay. I've rattled through that pretty quick. That's all from me. Thank you.
Thanks, Andy. Next, we've got Alberto Avila. I don't know if he's made it across from ScottishPower offices. We could do, we'll do an interim panel Q&A while it's still fresh in everyone's mind from the first two presentations. So I'd like to open up questions for both Ross and Andy Kay on the first two challenges, which are actually quite well linked around Subsea. So if anybody has any questions at the back there, love to.
One for Andy. Quality of cable inspections. Do you have any performance criteria around that? So, down to what, 5 centimetres crack, or are we talking about actual kind of catastrophic failure in the cabling? Is there any kind of other situation scenario that you want to see as part of the monitoring? Also, the actual communications, given that these are subsea vessels, chances are you may not get it completely in real time. So what does good look like?
Okay. So I think on the quality of the data that you're gathering, the main thing that they're going to be surveying for is going to be to make sure that the cables are buried and not free spanning or exposed or have moved. Maybe that's as part of a as-laid survey or as-built survey. And then during operations, it's just to maintain. One of the big problems happens is you get scour actually around the cables that cause the cables to be free spanning and move. So it's not so much about identifying cracks and small hairline faults within the cables themselves. Obviously that is an issue, and hopefully that will be picked up by the condition monitoring that you may then go and do a spot check with an ROV or something like that. But they're less common. The thing that's going to be routine that your technology is going to be applied more for is doing that survey of the exposure. So you're looking at contour maps around the cable of, I think 5 centimeters is possibly not achievable. So maybe 0.5 meter resolution contour maps around the cable.
And as part of this, do you have any current performance criteria around that we might be able to kind of measure ourselves against, such that we know whether we are actually better than current performance? So you mentioned, for example, 600 meters of cabling. How often is that done? How much of that is done? How long does it take? That type of thing.
Okay. So as I said, an operator will be going out there and doing their subsea survey of the site, usually as part of the consent requirements during the first 3 to 5 years. I think if you can focus on the operators that have that challenge, because beyond the first 3 to 5 years, it's completely up to their discretion when and how they do the surveys. But during the first 3 to 5 years, they have a requirement to survey every cable route and every foundation or the seabed. So what they'll tend to do is split the wind farm up into maybe a number of areas, maybe 4 quadrants, and they'll go out and survey the wind farm once a year. And as part of that survey, they'll maybe do spot checks of every foundation and cable route within a certain quadrant. And then the next year, they'll do the next quadrant. So every cable route should get surveyed once every 4 years. And every foundation maybe once every 5 years. I think that'd be pretty good going if you could achieve that. But I think beyond the consent phase, where they've had to do this as part of the Marine Authority consent, it costs a lot of money to go out and do these surveys. So they're going to just say, look, if we don't need to do it, let's not do it. But that's maybe not ideal because you're not getting enough information about your assets. So if you could have something that removes the cost, I'm sure they'd appreciate having higher frequency information on their cables and foundations, maybe once every 6 months, each cable route, each foundation. I don't know, kind of. It's case by case, yeah.
Another question there.
Another question for Andy, just a notional question on cost. You mentioned 800K in your PowerPoint. Is that 800K per turbine?
No, that's per site. So
irrespective of the size of the site?
Well, no, it's going to be site specific. So let's say for a representative 500 megawatt wind farm turbine of say 140 turbines, you could probably guess which one that is, then that's what the costs can be, around 800K. So that's per year. So that's over the whole course of the year. They might be able to do one survey on one kind of visit, but it's likely going to maybe take a couple of visits. But to get the whole wind farm surveyed in terms of the seabed, the cable routes, and the foundations, or a handful of the foundations, it's going to cost around 800K.
Sorry, Andy, is that in the initial project development phase? Or is that the operational phase?
No, that's the operational phase.
So that's ongoing monitoring.
That's ongoing monitoring. I think in the development phase, I'm not so sure, but you don't have any foundations or cables installed. So you're just surveying the seabed. So I'm not sure how the costs compare, but you're obviously wanting to do more survey work to make sure that the site is suitable.
But presumably the point here is that the more we can monitor the survey, the more we understand about our asset, the less we pay on insurance, the more we can control. So if we could do more surveying, that's also good to be valued by the end market.
Exactly. Yeah, definitely. You know, I think the current level of surveying is not optimized, and that's mainly due to the cost. So get the cost down, more data, more understanding of your asset. Yeah.
Okay, there's a question at the back, and if you're comfortable enough to sort of give yourself, well, an introduction of which company you're from, unless you're trying to stay anonymous, that'd be great. Thank you.
Okay, I'll be the first. So this question's to Ross. My name is Roger Hampson. I'm the MD of AP Sensing. Ross, you mentioned that you already have some experience of DTS and DSTS, but I probably know where it came from originally. The company I work for has their own DTS. They also have DAS, Distributed Acoustic Sensing, their own RTTR, real-time rating. We'd be looking to deploy our own technology and do our own data mining and analysis. Would that be acceptable rather than having to utilize the existing asset that you've got?
We're talking in terms of how the system would be analysed or how the data would be processed, or are we talking about how you would actually implement the system?
Well, we have an integrated platform, so we'd be wanting to plug our own instruments into our own platform, collect the data, then do the data mining and do the analysis, ultimately ending up with trend analysis of the installation.
Yeah, it's something we would potentially be open to. I think it's quite important that we are able to have at least a view of the data. If it's real-time data, for example, we would appreciate being able to interrogate it through our own SCADA system, whether that be a kind of front end to your own system. Yeah, it's once the wind farm becomes operational, our operations and maintenance team will take control. So one of their kind of parameters will be that they have visibility of what's going on with the cables. They don't want to find out the day after the event that something's went wrong. Ideally, they would be able to plot the trends as you guys would, so that they can almost try and preempt a failure.
Any further questions on the first two? Oh, Andy.
Thank you, Andy McDonald from the Catapult. It was just a clarification, Ross, just on the challenge, just to see is the challenge purely about technology solution for the monitoring, or is actually a kind of smaller part of that which is on the data analysis side? So I guess my question is, for the data that you already have, are you comfortable that you've done all the data analysis and that side of things that you can do, or is that actually another solution that would help you to get more out of what you've already got?
I think what we're looking for is a system which, for the least amount of equipment and cost, can get the most kind of back, the most active real-time data we can get. Let's say at the moment we can measure things like strain and temperature on the cables, which can then identify issues. But if we are able to measure things like current in the cable, we can then implement things like dynamic rating of the cable, so we can potentially put more power down a certain cable for a certain period of time. So yeah, what we're looking for is basically an expansion of the existing systems we've got. I dropped a few hints aiming towards the fibre optic installation in the cable, realistically, to keep costs down. If the system could utilise the fibre optic for more than what it does at the moment, you know, basically converting electrical signals into optical signals. We believe that that could be a cost-effective way of giving us more data, more visibility. I'm not sure if that quite answers the question, but
no, Scott, I'm just saying if there's a kind of sub-challenge there, just for the data analysis piece that's separate from the actual technology.
I mean, in terms of the analysis itself, the guys who would man the system day to day, the guys who monitor our SCADA, they may not be electrical engineers. What they would look for are basic indicators of, you know, temperature rising above a certain threshold, or a cable that's, you know, the insulation suddenly started to drop off, the quality of the insulation, for example, that they can then refer to someone who knows, you know, what that indicates. So it's the first step is to give us a warning signal before anything goes wrong, and then we can analyse the data in a bit more detail to try and work out the cause or the potential issue.
Thank you.
Anything further on the first two? Do we have anything via the web link as well? Any questions? And if you are on the web link, feel free to send in any questions. They're all perfectly satisfied. The quality of the presentation is obviously excellent. So next up, we've got Alberto Avila to talk about these alternative pile jacket connection systems. So thanks.
Hello, good afternoon. So this is a topic related to immediate needs that we are experiencing already, and that it doesn't seem to be rocket science, but it's still giving us a lot of headaches. So we are confident that will help, like forums like yours will have a solution soon. So basically, routed connections for pre-piled jackets have issues, and we are trying to get rid of them, or at least to have an alternative. Basically, already in our previous project in the Baltic, we were in the limits of the on-bottom stability, and that was in the Baltic. Now we are developing Stanley 1 in the North Sea, and we are closer to that limits, and also re-engineering many works in the many parts of the method statement to be able to install within the limits specified by the guidelines. And also, obviously, all the routed connections need material, needs time. And in a place like the North Sea, with not the best weather windows for these conditions, that is challenging and very costly. And overall, something is wrong, something needs to change. So this is just a quick reference to the guidelines. We're referring to benign areas, wave height of 2.5 meters as a condition for the bottom stability for 1 year. In non-benign areas, 5 meters. Well, in the North Sea, even the 5 meters are not enough, are still very challenging. And it's not only that, is also the curing times, the temperatures of the water. So there are many challenges that clearly need addressing, including better interpretations of these guidelines of marine warranty surveyor. On top of that, as said before, the routed connections have several other issues. At the end, that's a proven technology, but also very old-fashioned solution. We have seen in many locations how very expensive and costly reparation projects have been conducted to solve problems with the routed connections. They have problems with the early loading and with the early cycling loading. And as we progress into the deeper waters, the quality assurance and quality control of the routed connections is also more expensive and less reliable. Also, the current designs and the situation with much slimmer structures requires now only high strength grouted materials that are very costly as well. And obviously that's a risky subsea operations, not even now by diving, but by ROVs, but it's still risky. So the objective, at the end, it shouldn't be rocket science, and technology is at a point where there are plenty of mechanical elements, hydraulics, electronics, activation that should be able to be integrated in a solution for installing pre-piled jackets in offshore wind. The problem is that we still need to select the best components and to integrate them. So the objective of a project on this should be to develop already an integrated system that improves the on-bottom stability, reduce the utilization of vessels during installation. Obviously, if the grouting spreads and the grouting materials could be eliminated from the equation, energy costs will be much more competitive. And also this, considering the weather windows required, makes also the costs to improve even bigger. The expectation again is to develop some sort of mechanical connection, for example, grippers or clamps. We are in parallel investigating options with grippers. This system should be remotely activated. So instead of, like with the grouting connections, needing to put activities at subsea or surveillance of those activities with ROVs, if it is mechanical, there should be a way that it is activated from the platform, and obviously with the system installed at the fabrication yard. Also, obviously depending on the different elements, it can be like a definitive alternative to the grouted connection, or it can be something temporarily, something that is for a short lifetime, enough to have flexibility during the installation period until the grouted connection is installed. Or, and in the same way, it can be something that provides the total stability required, or that participates increasing or improving the on-bottom stability. So it doesn't need to be the final solution or the complete changing of from the grouting connections, but it needs to be something that helps to have flexibility for installation. Basically, the challenge we're facing now is that we need to have a grouting spread readily available to follow the pace of the jackets installation vessel, and that is very expensive, and we need weather windows for the two activities combined. So anything that is partial or simply increases availability of those weather windows will be of much help. Again, we know that there are solutions being used around, but not at a level that they can be common for the whole industry, and not at the level that they can be addressed and used with confidence by the different contractors. So again, not being something extremely complicated in terms of technology, it should be something achievable to develop in the short mid-term and easily for commercial deployment in the following few years for the following wind farms.
And so next up we have Javier Rodriguez to talk about the wind measurement challenge. And then we'll have a big Q&A session for the whole panel at the end.
Hello, good afternoon, everybody. Thank you for coming. Well, I'm going to, my presentation will be focused on the operational phase of the offshore wind projects, especially in power curve performance monitoring. So the pre-construction energy estimates of one of our projects, and therefore the project feasibility, depends strongly on the accuracy of the theoretical power curve provided by the turbine manufacturer in very early phases of the project, and exactly in the same way, the project performance during the operational phase is linked with the turbine power curve performance across the project lifetime. Therefore, it's essential for us as a project owner to have very accurate methods to test and monitor the power curve performance during all the project lifetime, widely accepted by the turbine manufacturers, of course. Currently, the usual contractual power curve measurement procedures accepted by OEMs are based on the guidelines IEC that in offshore is abandoned by developers due to the cost of the required fixed offshore med mast, or recently through nacelle LiDAR technology. Well, only as a curiosity here, you can see in the left photograph our West 2000 offshore wind project, where we have been conducting, or we are conducting, power curve monitoring and assessments through a fixed med mast, but also through LiDAR, through a floating LiDAR. And in the right side, our Vikinger offshore wind farm in Germany, where we have recently installed 2 nacelle LiDARs on 2 turbines. So LiDAR technology has significantly evolved during last years, becoming an efficient and totally reliable alternative for offshore power curve verification to the old IEC normative needing a med mast, and has already become one widely used alternative to conduct power curve measurements offshore, accepted by most of the turbine manufacturers. Even there's an international work group working on the development of one IEC normative through nacelle LiDAR, but hopefully by the end of this year will be published a first draft, and by the end of 2020 the normative will be ready. However, what we are facing just now is that the next generation of offshore turbines will have rotor diameters bigger than 200, 220, 240 meters. And this will difficult the application of the nacelle LiDAR technology for power curve testing. As you know, there's a well-known phenomenon in the wind farms is that we have a blockage effect. So as far as the wind speed is facing the turbines, there's a decrease in the wind speed in front of the turbines. That depends on the turbine side, but this can happen around 3 to 3.5 rotor diameter. So we will need to measure, if we want to measure at free stream, we'll need to measure up to 600 meters in front of the turbine. And currently, the state of the art of nacelle LiDAR technology only allows to measure accurately up to 400 meters, 450 more or less. So the challenge we will need in the close future for other alternatives. Ideally, those alternatives should fulfill as much as possible with compliance with current methods, so as accurate as current methods. Of course, low cost. We'll need also an easy and rapid deployment, no turbine downtime. So we will need simple devices in terms of size, weight, etc. Able to monitor all turbines in turn, and accurate and comprehensive long-term monitoring, as the idea of that is to be able to test the power curve performance of the different turbines during all the project lifetime. Future alternatives or future methods must be demonstrated through a set of track record of power performance testing validations. And one of the most significantly challenging things must secure OEM acceptance. That's complicated. Take into account that after conducting power curve performance monitoring, we have very detailed discussions with the turbine manufacturers in terms of well, the accuracy of the method. So there's partially one solution to that. That is a transition piece scanning LiDAR technology. Is currently the most promising cost-effective alternative to nacelle LiDAR, able to measure at distances well outside the compression zone, so in the free stream. Although this this alternative also needs some way to go in terms of deployment, size and weight of the device, and also acceptance of turbine manufacturers. So other alternatives needs to be developed, maybe also combined with some kind of wind modeling, although this will difficult the acceptance of the technique. Including also the uncertainty of the measurement, etc. So here in ScottishPower, there's an opportunity for us for all the industry. We are developing a project, an innovative project in our Avila 1 offshore wind farm. This wind farm is to consist of 108 turbines, Siemens 7 megawatt rate capacity, currently under construction, will be commissioned by early 2020. And we are going to implement here an innovative project installing a number of different devices, could be LiDAR technology or not, or the possibilities, in order to assess different techniques for power curve performance, and not only focus on power curve, but also in fatigue or wakes or improvement of the control system of the turbines in order to maximize the output. The project scoping and selection will be during this year and next one, and the measuring campaign will be conducted just after the project commissioning, so in 2020. So there's one possibility here to integrate this program in our Avila 1 test site activity. Well, that's all.
Thanks for that, Javier. And yeah, great to see that there's a potential route to a demonstration as well if you come through this program with a good opportunity there on EA1. So yeah, now's a chance to open up to the floor. You can ask any of the panelists questions if you didn't get the chance to ask on previous ones. So yeah, any questions on any of the four presentations? Perfect. Yeah, and Adam at the back there.
So obviously there's the four challenges. Firstly, are we able to go for more than one challenge? Secondly, if we've got technology that is focused on one challenge but is good leverage for a second challenge, is that possible? And thirdly, given the excellent networking that we have all done over lunch, if there's more than one company, two or more companies that we believe could work well together in formulating a solution that works for more than one challenge, is there space in the response to be able to do that also? I'm just thinking, something might be better than the sum of its parts.
Yeah, so from our perspective, I'm sure SPR will say for themselves as well, but from our perspective, consortiums absolutely welcome. And yeah, that would be encouraged where there's skills or expertise missing is to bring that in and put together a collaborative bid, and we can do set up a collaborative R&D project as part of this. Obviously the investors, that's more challenging for them because they want to invest in specific companies, but investment is only one facet of this. So first and foremost, we want good solutions going across the desks of SPR so that they can pick the best technology solutions, and if that comes from a consortium, that's fine. And to answer the previous question, if we just want the best solutions, so we're not precious about how many you want to go for. If you can apply for all four, great. Have a go. Yeah, far away. Andy.
So the wind speed measurement. So you said you're looking to measure beyond the induction zone of as the site get beyond, say, 600 meters, 3 rotor diameters upstream, something around that. Does the technology have to be able to detect the wind speeds that far in advance of the turbine? Or would you also consider a technology that's maybe measuring within the induction zone but is able to correlate what the wind speed would be outside?
both possibilities could be useful for us. Yeah. Currently, the usual approach is to try to measure outside the induction zone in the free stream, but as turbines are becoming more and more big, this could be more difficult in the future. So we have to be open to the possibility to measure within the induction zone, even very close to the hub, and correct these measurements. Because usually the theoretical power curve provided by the manufacturers are calculated in the free stream. Of course, each if you add more steps in the analysis, the more difficult you will have to obtain the acceptance of the turbine manufacturers. But we are open to all the possibilities. Yeah.
Any further questions? Yeah, Matt.
Matthew Smith from Zephyr LiDAR. Just a question for Javier. So you said that the OEMs have to accept the methodologies. Does that mean that Siemens are going to be consulted, you know, when you're looking at the possible solutions for this particular theme? Is that something which you'll be looking at?
Well, when we monitor the power performance of one of our projects and we obtain some results with any technique, at the end those results are discussed with turbine manufacturers. If we have detected some kind of degradation in the power performance across time, for instance, there are, as you can imagine, significant discussions that involve a lot of economical issues with the turbine suppliers. And one of the issues is the acceptance by all the parties of the technique. So it's important, the acceptance of so that everybody on the table needs to accept the technique. And in the case of Itsanglia 1, we are discussing with Siemens about this project, and yes, we will obtain his feedback about that. But well, it's a test site or a test activity, so it's not so important there to obtain a prior acceptance of the turbine manufacturers at that point.
Okay, thank you.
So if you have to achieve that acceptance, would it have to conform to an existing standards? You talked about the new standards that are coming out from this LiDAR. Would it have to conform, or do you think you could arrive at a situation where between you and Siemens, you both agree on a methodology, on an approach? It might differentiate slightly from the standard. It would adhere to it as much as it could, but it might differentiate slightly. And within your timescales for East Anglia 1, you could possibly agree on an approach that that does slightly, differentiate from the standard.
Yes, it's possible. Yeah, you can agree with a turbine manufacturer one procedure, not based on a standard, and in fact, all the developers are doing that. That's now currently through NASA LiDAR, but in the future we will need to make that with other methodologies.
Okay, Steve White.
Thank you. So on the pin piles and jacket interface challenge, I was trying to work out, are there existing problems that you'd look to try and retrofit a solution to, or is this about new installations?
It would have been good to have a solution now, but for the next project, in our case, East Anglia 3, it would be essential to have a solution. Yeah.
Thanks.
Trevor, is that a question?
This is the closest one. Sorry. Trevor Hodgson, Atkins, S&C Lavalin. Two questions really on the monitoring and inspection side. The presentations seem rather prescriptive on, looking at a particular aspect of it. I think it's already been mentioned that, maybe better use of the data might be another way of looking at it, or, maybe having semi-intelligent structures that sense. Is there a limit on, what can be looked at there?
Yeah, so I think with any solution, it would be prudent to think both about the method of capturing the data and then how you then process and analyze that, provide some useful information back to SPR on what action they should take or what could inform their designs. So yes, it should, or it would be good to have some thought into the data processing, but you're trying to overcome the existing challenges around costs of gathering the data mainly. That's the limiting factor at the minute. It's the cost of going out there and capturing that data. There's nothing to say that those techniques aren't good at getting the data, it's just the cost of doing it. So the real focus should be on reducing that cost, gathering equivalent data, but then if you can also show how a system you have can then bring that in and categorize it and provide some kind of survey report or maintenance plan, that would also be useful, but the focus should be on the technique of capturing the data.
Sorry, there was another question as well as on the pin piles. Are you restricting this to looking at pre-driven piling and with accepted tolerances and such like on the pile positioning?
I think probably if something is developed, probably is equally valid for post-piles jackets. But so far, probably I'm stressing the pre-piling because it's the challenge we are facing right now. But probably it's applicable to post-pile.
Okay, any further questions from the floor? Any from the web link at all? Oh, sorry, yeah, Adam.
Yeah, just one around the subsea cabling. Obviously, as part of that, you were looking at doing some level of forecasting around what if a company is successful in this process, would we be able to have access to some level of historic data? I'm just thinking about machine learning and that type of thing. The best, the better the data you put in, the better and quicker you get more refined results coming back out. Just wondering if there was access to that data, and in your view, how good quality that data is.
Yeah, I mean, I assume you're referring to data from our operational wind farms. Yeah, I mean, I suppose with the proper NDAs and things in place, which would be part of the course, I think I can't see any issue with sharing that data as long as it's protected. In terms of how useful it is, we've recently moved up from, well, certainly in terms of the array cables, we've moved from 33 to 66. EA1 being 66 and previous projects being at 33. So how useful that data is to you, that's for you guys to decide. But yeah, to answer the question, as long as the NDA was in place, I think sharing of previous data as well as any technical data shouldn't be an issue.
Okay, that looks like it's just about it from everyone, unless there's any further questions. Oh, right, one online.
So we've got a question from online. It says, do you believe these new resource estimation and data gathering could help to unlock Scottish sites, surely the most important European wind market, as well as to be applicable to floating wind? This will be something ScottishPower will be pursuing in coming years. Question mark.
So who's on the panel? Yeah, is that for you?
Yes, power performance assessment in theory is not, it's an agnostic matter regarding geographical location or even the floating for floating solutions or whatever. Yes, it's another future requirement here.
Okay. So yeah, I guess that leaves us, we finished up slightly early, so you've got a few minutes to go out there and have, I don't know if we've got tea, I hope we've got tea, to go and have a chat. And, you know, if you've got questions that you didn't feel like putting your hand up or you wanted to remain incognito, then you can catch some of these guys afterwards. And yeah, hopefully we'll see some of your applications coming in over the next few weeks. Don't forget the, I believe it's the 21st of June, the deadline. So have a look on our website, have a look at the challenges in more detail. You can look through, well, there's quite a detailed description of each challenge in there if you've missed anything. And yeah, if you've got any questions during the process, I think my details are on the challenge web page. And yeah, so all I can say really is good luck. And yeah, hopefully we'll be seeing some of you in the pitch event in the not too distant future. Thank you. Oh, and a round of applause for all the speakers as well.
Yeah.